All right. So section 5% of change. Now, a lot of the students have recognized how similar this is compared to everything else we've done, hence the unit. Okay. However, there's a slight difference, and there's only 2 concepts to know in this one. So, all right. So, like, keep in mind, keep your mask over your nose, please. Over your nose. And if your mask is too big, you can twist before you put it over your ears, and that will help it keep there. I have a lot of masks. I have a lot of masks that do not do what they're supposed to do, and those are my backups, my emergency backups. Yeah. Yeah, yep, and that's what the CDC recommends. All right, here we go. Because I'm recording this, I want to try to get through this as fast as possible. Want to fill that up? Okay. All right. Speed Racer. The Indy 500 is one of the world's great motor races. The table shows the average speed of the winning race cars for various years. So back in 1922, the fastest average time for the winner was 94 miles per hour. However, in 1955, it jumped all the way up to 128 miles per hour. And then in 2010, 162 miles per hour. So it says, write the ratio. We're going to find the speed increase from 1922 to 1955, and we're going to put that over the speed of 1922. So the difference between these two, so we're going to go 94. We're going to subtract that from 128. And we subtract 128 from 94. That's going to be 28 plus 6, which is 130. So 30, what is it? 34. 34. So we have 34. Now I want you in your calculator to do 34 divided by the original speed, which was 94. The 1922 speed, what we got? 30%. 34 divided by 94. 27%.
34 divided by 94?
Yeah. 2.76.
You're 26. I got 36.
All right, I'm not trusting you guys. It's 36%. Then we have the speed increase from 55 to 2010. So it's 162 minus 128. And we get another 34 miles per hour. So can I trust you guys this time to actually do the division? 34 divided by 128? 36.5. So we're going to... There's the 26. So 26.5, let's round it to 27. So then number 3 asks us, why are the amounts of increase the same, but the percents different? Why is it? The denominator is different. Yes, different denominator. That looks like a Disney D. Yeah. No. This is only for people who are absent today to be able to watch it. Different denominator. No, this is only to save it. Different. No. No, I'm only using Zoom to record it. Like as in, if there were to be somebody that were to join this meeting, I wouldn't bring them in. Yeah. 162 minus 128, because the question asked us the speed increase from 1955 to 2010, and we're finding a difference. So we're finding the increase, that's a difference. So we take 2010 minus 1955 speeds. Good question. So once again, if you're ever wondering how to do something in your homework, when you look at your notes, whether it's the examples that you benefit from or all the examples that are given to you, the pink ovals or the pink boxes, those are going to be the major concepts. And you'll have 2 of them in this section. And if you're ever studying for something, it's like, okay, what do I need to know for this test? It's going to be the stuff that's in the pink boxes. For this one, the percentage change is a ratio that compares the change of quantity to the original amount. So you have the amount of change, which is a difference, which is subtraction, over the original amount. When you compare the amount of change to the original amount in a ratio, you are finding the percentage of change. The percent of change is based on the original amount. That's the big thing, the original amount in the denominator. So we have, if the original quantities increase, then it is called the percent of increase. Whenever you find the difference, if you come up with a negative number, you don't have to use negatives when you enter this homework on the Schoology today. It'll just be a percentage, and then you would just say increase or decrease. You don't have to have a negative. Even though the percentage might be negative, you can just say that it's a decrease if it's a negative. So we have percent of increase, the amount of increase over the original amount, the amount of decrease over the original amount. Let's look at an example. Find the percentage of change of the cost of gasoline, and I know that your book says something different. This is apparently updated more. From 1970 to 2010, round to the nearest percent if necessary. Since the price of 2010 is greater than the price of 1970, this is a percent increase. It is a percent increase. So to find the percent, we get the difference of 295 minus 130 is 165. We found the amount of increase, which is 165, and we put that over the original amount. So when we do this, since we're going to be rounding, notice how the equal sign turns into an about equals sign. Or as someone said in first period, it looks like a toothpaste. Someone said like toothpaste equal sign. That's fun. So the cost of gasoline increased by 127% from 1970 to 2010. Yeah, well, I mean, and also the price of gas changes every single day. Sometimes, depending on the gas station, it'll change multiple times a day. Yeah, exactly. Yusuf bought a DVD recorder. How many of you know what a DVD recorder is? Okay. So that's about halfway between first period and second period. For $280. Now it's on sale for $220, which that's way, like, DVD recorders were not that expensive after like the first year. Yeah. And then they just went down, and then you could eventually get them for like $20 from Walmart. But find the percent of change and round to the nearest percent if necessary. Since the new price is less than the original price, this is a percent of decrease. So the main concept is we're finding the difference. We're finding the difference. Whether it went up or down, you want to find the difference. So we're subtracting. 280 minus 220 is $60. Find the percent of decrease. So we have the amount of decrease. The amount of decrease over the original price. So 60 divided by 280 is 0.21. And we move the decimal place over 2 spots, and that is 21%. So we're going to find the percent of change from 10 yards to 13 yards. So what we would do is I would take the difference, which is 13 minus 10. And although that's a simple question, I do want you to write what I just wrote. Close. What? Darn it. Oh, you just tricked my brain. So that's a perfect example of me doing the whole teaching and doing others. Wow, that was good. All right, so 13 minus 10 is 3, not 4. So I know you had it right. You just tricked me. So 13 minus 10 is 3. I put the difference over the original because we went from, nope. We went from 3 to 10, from 10 to 13. Now my brain is messed up. Three divided by 10 is 0.3, which is, come on. Why? Wow, the collaboration is off. There we go. So that's 30%. Now it's not only a 30%, it's a 30% increase. 30% increase. Yeah. Yep. Because I don't want a negative number, and I'm just finding the difference of the original and what happened. Since we said increase, we would never say a negative. If it went from 13 down to 10, then it would be, no, because it's still a difference. Subtract the smaller number from the bigger number, and it would just say the percentage decrease. We'll get to that. We'll get to that. Yeah, by saying decrease, that represents the negative. So the price of a radio, here's a decrease. The price of a radio is $20. It's on sale for 15 bucks. What is the percentage of change in the price ratio? So I would do, even though you can do this in your head, I'm going to find the difference, which is 5. I'm going to put that over the original price because I'm finding the difference in price. So I put the original price in the denominator. Yes, sir. Yes, because that you're finding the difference of them too. The question just was, do I take the bigger number and subtract the smaller number? Yes, because we're finding a difference. So 5 divided by 20 is what? 0.25, which is 25% decrease. No. You'd say 0.25 or 25 hundredths. So there's the end of the first concept of this homework. The second one, so you're just hanging out? I'm not a babysitter, my dude. Where's your book? Bring it. When you have math in a day, bring your math book. Like, this is not the first time this has happened. However, I'm not trying to perform for you, so write down what I'm writing down. This shouldn't be a novel concept. Percent error. The percent error is a ratio that compares the inaccuracy of an estimate or amount of error to an actual amount. So you would have the amount of error. So we're finding the difference between what we guessed compared to what the actual thing is over the actual thing. Finding the percent error is similar to finding the percent of change instead of finding the amount of increase or decrease. Find an increase or decrease, you will find the amount estimate is greater or less than the actual amount. Once again, we're going to say increase or decrease rather than using a negative number. If you didn't say increase or decrease, then you could have a negative number. So keep in mind that if the question that we had right here, where it was a 25% decrease, you could also reword that as saying it reduced by 25%. You could also say negative 25%. That was the change. Yeah. Oh, not my phone. Shoot. Heck no. Heck no. I don't like that. I don't like that phone. It's a great phone, but not for me. What's up? Mm-hmm. Yeah, stocks. Yeah, that's a percentage of change. They'll give you the percentage. Usually the number is negative, and it'll also show up red. No, I want you on the homework. It says that you have to put whether it's an increase or decrease. Yeah, and when you do it on Schoology, it'll show quiet. On Schoology, it will show you the percentage, and then you'll have an option to do increase or decrease. And both numbers, like let's say something, your answer is 13%. If it has 13% increase, that'll be an option. If it shows 13% decrease, that'll also be an option. So for this one here, we guess that there are 300 gumballs in a jar, but there are actually 400. Mm-hmm. That's a huge miscalculation. So what they did was they found the difference of what they guessed over the actual, which is 25%. Another example. Ahmed wants to practice free throws. For those of you that don't know what a basketball is, that's when you shoot a ball into the hoop and it's 1 point.
It can be 2 points in club ball.
Really? Ugh. Well, no, one at a time. 1 point at a time. Yeah. Yeah, okay, yeah. So he estimates the distance of a free throw line in a hoop. So let's say that he's in his driveway. Okay, so he draws a line that is 13.5 feet because he didn't have the information to see that it's 15. So drew a line for shooting free throws in his garage or driveway, but the actual distance is 15 feet. So he found the percentage error. What you did is found the difference between the actual and what he estimated, and you put that over the actual. So the difference was 1.5 feet over the actual, which is 15. 1.5 divided by 15 is 0.1 or 10%. Find the percent error if the estimate is $230 and the actual amount is $245. Round to the nearest percent. So what I would do here is I'd find the difference, 245 minus 230, which is 15. You writing that? So just as a reminder, since day one, if I write something, you write something unless I tell you otherwise. Because this is guided notes and you're being guided. So the actual amount is 245. So you divide 15 by 245, and what's the percentage of error? What you got, Sam? 6%? 0.06 is 6%. Because you move the decimal point 2 points over. Is that what we just figured out? Is that what it is? Is that the inches? I'm asking about what you just said. Okay. Okay. I would like you all to do numbers 1, 2, and 3 right now. I'm going to pause the video and I'll come back and give you the answers. For number 1, first things first, when you go from 30 to 24, you know it's going to be a decrease. I'm writing more than you might have done because you know that 30 minus 24 is 6. 30 minus 24 is 6. I have the difference over the original, which is what? Someone raise your hand. Yeah, Sam? 20%. For this one, we have, that's a decrease. Decrease. For this one, it's going to be an increase. Yeah, you can tell if it's an increase or decrease right when you look at it. So we have the difference over the original. Yeah. Is it 16? Got backup on that? Oh boy. 24 divided by 126. 19. 19% increase. So if number one, you got a negative number because you did 24 minus 13, no, 24 minus 30, you would have a negative 6. So if it's a negative percentage, you just say a positive percentage and say decrease, and that takes care of the negative. Jessie estimates her cat to be 10 pounds. The actual weight was 13.75 pounds. So I'm going to, it might be a big cat, who knows? So I took the actual weight minus the estimate, and I'm going to put that over the actual weight. So 3.25 divided by 13.75, we get, Graham, what you got? %. We got backup on that? All right. 37 point what? 0.5. So it said to round to the nearest highest percentage. So 38%. And that was 38% off. But since this is a comparison to an estimate, there's not an increase or decrease. Is that understood? Okay. All right, I don't trust you guys. I got 20. Yeah, 27.2. %. All right, so how the amounts of change can be the same, but the percentages can be different? It's going to be different denominators. $10? No, with estimations, you put the actual number in the denominator. Good question. Yeah, it should be 13.75. So we have different denominators and different original numbers. And different original numbers. Yes.